Welcome for this first video about logic. Today we have 4 goals. First, the truth table. Second, simplify. Third, normal form. And fourth, quantifiers. With the truth tables, the most important part is that false implies everything. Simplify, we will have 3 laws to simplify those kind of things. Normal form, we have a definition and it's gonna be easy once you know the definition. Quantifiers, we just have to know how to negate it. It's actually easy once you know how. So, what do we have to remember? First, we have to remember the law from De Morgan. When you have not A and B, it's equivalent to not A or not B. A way to understand it would be if you don't have A, then you don't have A and B at the same time, right? Once you understood how this works, it's the same with this one. A really easy way to remember it, the not gets distributed inside, and the and becomes a or becomes an and. Now we have a distributive law. It's a bit like multiplication and plus. So A and B or C becomes A and B or A and C. Same idea with the second one. This is what I mean by this is the same as multiplication and plus. Next we would call the implication removing law. There was no name, so it's easier to put a name on something so that you can remember it. And implication removing law, or of German Implikationsauflösungsgesetz, it's just called like that because we have an implication here and it's equivalent to something without the implication. For A implies B, it's the same as not A or B. Not A implies B is the same as A and not B. Why did I select those 3 laws? It's because I made many exercises on the topic, and those 3 laws were the one that always came back. And I didn't need any other law for those exercises. One more thing, in the course we saw also that we have a time waste. By that I mean that if you have such a thing, it's likely gonna waste your time to just use the distributive law on that one. So either you remember all the possible cases, or easier, like I do, you just use a truth table. More on that on the exercises we are going to do later. So for the truth tables, you have to remember that false implies everything. By that I mean that false implies true, but is true. False implies false is also true. Why is that so? Let's take an example. If you start with 0 equals to 1, then you can say whatever you want, but of course it won't be true. But the fact that when you start from something false, whatever it does is gonna be true, the assertion, is what we have to remember. How many rows should I prepare? That's just a small remark that can be useful to not lose so much time on the exercises. So when you have 2 assertions, for example A and B, we only need 4 rows, 1, 2, 3, and 4. But if you have A, B, and C, you need 4. So for A it will be 0, 0, 0, 0, 1, 1, 1, 1, with 0 standing for false and 1 standing for true. And if you're A, B, C, D, you would need 8 rows. So actually you just multiply by 2 each time. Maybe that can be useful for some exercises just to be remembered. Now for the normal form. So there are 2 types of normal forms, the disjunctive normal form and the conjunctive normal form. I used the German abbreviation. What do we have to remember? For the disjunctive normal form, we have or outside. And for the conjunctive normal form, we have and outside. So how to build them? Here we have an example with A and B and an assertion. This assertion could be anything, but in our example, it could be, for example, not A or B. It's just an example, okay? So in our example, it's not A. And what would be the disjunctive normal form from this? You just took the cases where the assertion is true. here this row or this row. Then we just write it. So this is true when A is wrong and B is wrong, or when A is wrong and B is true. So it's easy to do the disjunctive Normalform for annotation. What about the conjunctive Normalform? So this is easy. You just have to remember that you have first to do the disjunctive Normalform from not alpha. So you look when not alpha is true, this row and this row. We build the disjunctive Normalform from not alpha. So A and not B, or A and B. And then we just do not from this whole thing. And here we use the De Morgan law. So it's gonna be not this thing and not this thing. Like that. And then we have the conjunctive Normalform of alpha. So remember, conjunctive Normalform means this symbol outside, so the other symbol inside. And here, disjunctive Normalform from alpha means this symbol outside and this symbol inside. Now let's go for the quantifiers. We have two important quantifiers, for all and it exists. So usually we have something with like for all there is something so that something is true. And to build the negation of it, we just replace all the for all by there is. There is by for all. And we do the negation of this, which will be for this symbol, this symbol. But if you had, for example, equal here instead, the negation would of course be something like that. And this is the only thing you have to remember about quantifiers. We did see the normal form and quantifiers. I also explained some stuff about truth tables and simplifiers. But we are going to do exercises about the two first, because here we have the most things to learn. Here you go, let's practice. Break the video and do the two following exercises. By the way, in the first exercise, I ask you to do the truth table for A, X, or B. And XOR, by that I mean it's the operator that is true only when either A or B is true. See you after the break. Okay, I hope you did the exercise. Let's correct them. Here we have a truth table for A, X, or B. So there are two methods, which are actually really similar. The first method is just you write A, B, and XOR at the end. So A is wrong, A is true, like that. And then you have XOR. XOR is true only when at least there is one here. So here wrong, 1, 1, 0. And here in this method, we look A, B, we write 1 and 1 here, because we do that and that at the same time, and then we compare. This is easy because it's only XOR, there's only one case. Sometimes the assertions are a lot longer, so you have to pay attention about the order, and sometimes I find this method easier, and sometimes this method easier. You have to see for yourself, it really is personal preference. So now, for the DNF of A, X, or B, this is the one. We just look at this column and this column. And for the K and F, so the conjunctive Normalform from A, X, or B, we end up finding this. Now let's go for the last exercises. So there are many steps, but it's only using those three main laws. So we start by rewriting it in the right direction, because it's just easier to see. After that, we have a case where we have A here, like let's call this all block A, and this all called block B. Then remember the law of implication removing. You can have A implies B, the same as not A or B. So exactly what we are doing here, not A or B. And after that, we just put the not inside. So with the Morgan, it's gonna enter and it's gonna be not A or not B. So the step I'm doing here, you could also do them in another order. It would also work. So don't worry if you did it differently, if at the end you have the same result, okay? So here I did the Morgan, and after that I did again this implication removing law. This time the other one for not A implies B, which is this one. Not A implies B is equivalent to A and not B. So to remember, here you actually have not A or B, and here you have A and not B. So there's only a not, either A or N or B, and I did this for step 3, and then I saw here that here and here I have the same thing, so I remember, okay, careful, if I develop like with a distributive law, there's a risk that I turn in cycle. So instead of wasting my time, I directly did a truth table, and I had that. Then I did this step here and there, and then at the end I had this step here. So I use the second method that we saw for the truth tables. And I saw by comparing this column and this column, they were the same. Therefore, this is the same as not B. And then I see that and that. Another thing which is important to remember is I put the bracket just to better read. But here I see there is or and or. So it's the same symbol. It would be the same if you see here and end. Therefore you can remove the bracket and simplify it. Since here we have not B or B, B doesn't matter at all. Therefore this what remains is A. So this whole thing, if I didn't make any mistake, is equivalent to A. That's it for today. See you tomorrow at 7 AM for the next video.